Okay, so now we're going to talk about the squeeze theorem, which is essentially the only tool we will have in order to show that a limit exists, because the other possibility would be to work with epsilon delta definitions, which we definitely do not want to do here. So again, we're studying this expression x cubed plus y cubed over x squared plus y squared. Notice that this one is only undefined at the origin. And we want to approach this as you go towards the origin. So again, the whole point is that if this were another point like 1, 1, you would get 2 over 2. You could just find the limit by plugging in the numbers, and you would just get 2 over 2, which is 1. But what makes this interesting is that you need to do something else, right? So now, how can you come up with a solution in this case? Well, the idea is that this is we can do the same sort of power analysis that as we did before. The numerator is like cubic in nature, right? Because each of the terms is cubic, so the numerator is like cubic, and the denominator is quadratic, right? Because each of the terms is quadratic. And so something cubic over something quadratic is linear, and so something linear should go to 0 as you move towards the origin. And so in this case, you do expect a limit which should be 0. So here, expect a limit. So in this case, you would expect some limit. But now, the point is that since we do expect a limit, we cannot just start playing around with curves to show that the limit gives 0, because it doesn't matter how many particular curves you choose, that is not sufficient to know that the limit will exist. You need to try it for every possible curve in a sense, and that's not practical. So in this case, we have to do something else, which is work with the squeeze theorem, meaning if you remember the squeeze theorem from Calc 1, it would use like properties like say that sine or cosine are between -1 and 1, and hopefully that would bound the function between two things for which the limit you do understand. And so here we do something similar, which is just use polar coordinates, which you surely know. So here is 0, 0. This is the path point. Any other point you can choose polar coordinates, and so remember that if this is r theta and this is r, x equals r cosine of theta, y equals r sine of theta. And so with this expression saying that the limit goes to of x comma y going to 0, 0 of x cubed plus y cubed over x squared plus y squared, that's the same as saying that that the limit, if you change this in polar coordinates, x, y goes to 0, 0 can only happen if the distance to the origin goes to 0. So this is like the limit as r goes to 0. Theta can be anything that you want, because you don't need to approach the origin from a specific angle. So you only have control over theta, over r, and this becomes r cubed cosine cubed of theta plus r cubed sine cubed of theta over r squared cosine square of theta plus r squared sine square of theta. And now the point is that, well, you can factorize here r squared, so you get cosine squared plus sine squared, which is just 1, and so you get r squared in the numerator, in the denominator. And so this gives you the limit as r goes to 0 of r times cosine cubed of theta plus sine cubed of theta. And this is where we use the squeeze theorem. Because the idea is that we don't know what value theta is taking specifically, because you can again spiral down to the origin. So there's no specific bound for theta, but we do know that r is going to 0. The point is that cosine and sine, they are never too big, right? They cannot screw up the behavior of this expression because they're sort of always between 1 and 1. So in fact, you can, like for example, sine is always less than 1, so sine cubed is always less than 1. Same happens for cosine. And so you could say that this is always less than 2. And also, it can always, the smallest value that the most negative that this can be is -1. The most negative that this can be is -1. So you can just say that it's between -2 and 2. You could also say it's like between -100 and 100. Like you don't have to be super specific about the bounds. So you can just say that cosine, again, like even, I guess, between -1 and 1 should be fine also. But you don't need to be super precise. So if this is true, then this expression is between, when you multiply both sides by r, you get something like this. But we know that each of these is going to 0 individually as r goes to 0. And so by like a version of the squeeze theorem, this needs to go to 0 as well by squeeze theorem. And so in practice, that's how you would show that a certain limit is 0 or exists. Like, but you notice have to do a different argument, which is not the same as just finding trajectories that work.